My name is Trygve Karper. I'm currently the CEO of a company called DataButton, a startup that we started a year ago. We'll come briefly back to DataButton later, but that's not kind of the main topic today at all. So I'm going to talk about something, a kind of a learning experience, both for me and my previous employer, where we went around and we built custom data applications. I'll come back a bit to what I mean with data applications under very high expectations and pressure. Basically, a lot of ambitions that people wanted to realize. And I'll talk a bit about that. So for about 4 years, I was part of a company called Cognite. I was an early employee, like number 30, and I left when we were 700 employees. So it was quite a journey. And over those 4 years, I was fortunate enough to be part of and be included in the digitalization program and the efforts of some of the biggest energy companies in the world's attempt to become more data-driven. So of course they had looked at how they're operating today, and they have seen new big companies emerge over the past like 20 years, like Amazon, Google, Facebook, and so on, and seen how they use data and computers and software in order to deliver value in a totally new and different way. And they looked at their own way of operating and seen that over time, the way we operate won't be profitable anymore. So we need to change, and we need to start also to use data to change how we work and be more efficient, basically. So I think there's a lot of people walking around talking about like different algorithms and what they do and different best practices and how we do it and so on. But there's not that many people who go around talking about the things that was actually done and how it was done, and kind of the challenges that emerged over that period. So I would like to talk about that today, basically. So it all starts in the same way that a business wants to figure out how they can use data analytics in order to be more profitable, drive more value, cut costs, increase production, that kind of thing. And it starts by kind of trying to identify the most valuable but still scoped pieces of work or opportunities within the business, and then scope those kind of areas into projects, staff the projects, and then execute. So that's kind of the typical way when you want to try to change, right? You have to start some way. We were part of this from the get-go, like the identifications, the scoping, the staffing, and of course the execution too. So I would like to now take you through like some examples. We started this in late 2017, early 2018, and then I was part of that for 4 years, and I'll go through like different stages as we learned. So the first case I would like to talk about is a oil and gas compressor. I'm not sure how familiar you are with oil and gas production, but what you pump out of the oil reservoirs is not like a pure liquid. It's not only oil that comes up, but it's a mixture of like oil and gas and water and sand and so on. And if you've seen the production facilities, that's basically their job is to separate this. So they separate oil from gas, water from oil, and so on. And then they need to transport the gas somehow. The only way to transport gas then is to compress it so that it gets a higher pressure, so that you can transport it over a distance. And for that, they use compressors, like big compressors. So the picture, you can see a oil and gas compressor. So it's quite big, and they usually have like 3 or 4 of these in a train in order to get enough compression to drive the flow. Now, if one of these compressors stops, then they have to stop production, and stopping production is extremely expensive in the sense that they don't count that as kind of production you can make do for 20, 30 years later. It's just lost revenue. So it costs millions of dollars per minute that this thing stops. So high value case, provide early warning if this thing is going to have a stop, like some kind of condition is gonna stop it. They want early warning so they can operate it in a different way, plan maintenance around it, route production and maybe do the shutdown when it's more economical. The data we got in order to do this was sensor data. Like these are fitted with a lot of sensors, of course. We got prior shutdown events and prior maintenance events and like everything that has been done to it and all the documentation for it. So that was the beginning. So how do you execute on something like that, right? So this was back in 2018. So what we basically did was to start a project where we had 2 data scientists on the project, a project manager. This was like one group coming not from the customer side, but from our partner ours. They met with the people from the customers maybe once a week with like an hourly chat or something like that over Google Hangouts and sending like slide decks back and forth. So basically collaboration through talk. It ran for like 3 months, 1 week of testing, and then done basically. The solution you see to the left was kind of how the hell do we make something that is even running and doing something and so on. And back then we delivered a UI in Grafana, whereas the backend was running in Databricks, and we used SendGrid in order to send like email notifications when this big compressor was gonna shut down. And as part of Cognite, all the data was provided through Cognite's product, Cognite Data Fusion. So how did this go? Well, what was delivered was a clustering model. I don't know how much like data science and so on you know, but very, very basic clustering model where parts of on sensor data. So there was identified like a normal cluster for normal operation, and then an abnormal cluster for when it had an event, like a shutdown. And then the boundaries were tuned so that was a fit to historical data. So like the thresholds of what you call a cluster for normality and what you call a cluster for anomality was tuned to previous shutdown events. Now, what happened was that like 3 months into operation, the compressor was shaking so much that the people who worked there thought it was gonna like leave the facility on its own. So the model didn't catch that at all. Then the thresholds were retuned, and then it had 4 false alarms in like 1 month. So the whole model was like decommissioned. And that was the end of that project. So what happened really? Right? Why was this such a failure? And then some people would like dive into data quality and saying that it was not good enough data and quality was not good enough and so on. But I would like to highlight some other things. For instance, there were no actual testing over a period of time where you like were open to this thing not working, right? And maybe more thing was that there was no actual domain competence or experience with the actual thing in the project, even though they had access to domain expertise in the customer sites. The only collaboration was through talking, right? Like babbling over Google Hangouts once a week, which is not enough. Like the people with domain competence, they trust that the people that come in with the data science knowledge and so on know a lot more than they know, and that what they propose is sound, and they are not able to like question it in a fundamental manner or contribute with their domain knowledge in a fundamental way. So we learned quite a bit from that. So this is an example of a later project, which was more typical like of that period. We did lots of projects, but this is like a typical one. And that was on valve monitoring. So these oil and gas production facilities has a insane number of valves, which is not that strange, right? They need to be able to shut down regions when they do maintenance there, and they need to be able to adjust things and so on. So there are literally tens and thousands of valves on a single facility. Now, these valves need to be inspected to see that they work, but in 99.9% of the time, the inspection is unnecessary, and the inspection involves a shutdown, in the sense that you need to check if the valve can be closed and opened, and you monitor the open and close time and so on. So the case was basically to build a solution, data application, that notifies which valve you actually need to inspect and which you don't need to inspect right now. Again, we had the sensor data from the valves, like upstream, downstream sensor data, and also like valve closing times and so on. We had prior inspection events and what had happened to the valve in the previously, and we had the documentation for the valves. Now we had learned. So this time around, we did not like organize in the sense of like have one data science engineering team on its own and then some domain competence to come in and say some words over Google Hangouts. No, it was a co-located team that was working together for 4 months, only them together. So they were like taken out of their normal operation and only doing this. And we also include some more leadership to make sure that the communication towards the rest of the business was good. And we also now had a data engineer that was kind of supporting in the back end to get more data and so on. It was organized through like agile 2-week sprints with big demos. And at the end, there was a short rollout and handover to the business. On the solution side, we learned a bit. So we built something in Plotly instead now, which bit richer and a bit more custom, and it looked a bit better. And we had moved away from Databricks, which was extremely hard to maintain, into Google Cloud Functions, where we could like actually have some proper revision control and not have like one large notebook where that was running on a schedule. How did that go? Well, the solution was done. It was delivered and with a short rollout period and handover, but it was never actually adopted by the business, and eventually just not used anymore. And that was a big learning for us because even though we had the users in the team and we had domain experts and everything working together to build something good, the users are not users anymore when they're part of the team. They don't know themselves that well. So you didn't get the proper business buy-in from the rest of the users and the organization, because even though you had people from the organizations in the team, they were like taken out of their normal operations and didn't represent that anymore. And the iteration towards actual users were not good enough, and the testing in if they actually were gonna use it. So a person cannot even make software for themselves really, so you need to actually test it towards users in the right environment. So they made the wrong thing, basically. Then we had learned by the time we come to 2020, really learned and built. This is also a typical project from that time, where we did a solution, a data application around maintenance planning. So planning which maintenance tasks to do when and where, and built a tool around that. Again, that was of course maintenance record, sensor data, a 3D model, technical drawings were kind of data we had to work with, and the whole task was to optimize planning so that you don't. Often when you do maintenance, you need to shut down areas of the facility, and the point is not to having to shut down the same area multiple times over a course of months, right? But rather to lump together maintenance events in the same area when it's shut down, and that kind of optimization. Now the team had grown quite a bit. So now we had front-end people, we had data people, we had back-end people, we had data engineers, and we had infrastructure people helping it to keep it up, because now we had moved to like a proper front-end stack with Kubernetes, still running a lot of the back-end things on Google Cloud Functions. And we had project managers and domain experts, continuous co-location, agile 2-week sprints. But now we had learned that we need to like work and test for a longer period of time with the people. And you see that the evolution actually goes to like a proper product team around each data applications, right? So if you look at it today, this was a success and it's still in use across many facilities, but the project is also still running. So the people are still working on it. It's still continuously improved. It's still it's no handover. It's nothing like that. It's a proper product team delivering a product. So what did we learn over this period of time? We learned that domain competence is a must. You can't create data applications in these business settings without having people who know the domain very well. And domain competence is multifaceted. So one thing is to know about, like in the terms of oil and gas or energy, it's to know about oil and gas production and to know the right things about it. But it's also to know the business that you're creating a solution for and like how their business processes are working. And it's also on the data side to know the data and what the data actually means and what column number 11 from SAP is actually used for in this setting. So we learned that you need that kind of domain competence like in the team itself, and you need to have a strong collaboration. It's not enough to have like chats over slides or on a whiteboard. You need an extremely tight collaboration with actual users. So not users that are taking out of their normal job and sitting in the team acting as a kind of a product manager or something like that. No, they need to actually work and test it and so on. Maintenance of solutions needs to be extremely easy to do, right? Otherwise you will have a product team that is stuck there, and the time to first user interaction is just crucial. And that's back to point 2, really, that it's not until the first actual users start using it, getting value out of it, you understand anything of if you're creating the right thing or not, right? But we also saw that going from like small setups that were able to act on a short period of time with a small team, we now had like huge teams, huge iteration cycles, and the maintenance load just grow and grow and grow and grow, and it was still difficult to build the right thing, but of course much easier. So I think that was a big realization that this becomes very expensive. And when it becomes very expensive, also, if the ambition level becomes even higher, right? And the number of things like this you can execute becomes a lot smaller. But it's not that strange that building the right thing in data applications is very hard, right? Because there's so many parts that needs to be good, and it's spread across so many roles, right? You need to fetch the right data. You need to model that data in the right way. You need to do the modeling and analytics of that in order to get the results that you need. Often a lot of emphasis is putting on like the modeling and analytics side of it, but you also need to create the right user interfaces. And then you need to test that on people and get actual feedback if this is actionable and something they can use and will use. Like, it's not enough that something is like the value something need to provide in order for people to change how they work and change behavior is high. It's difficult. And then you need to like iterate on this whole thing, right? And normally if you scatter this across many roles so that you have one data engineer working with like connecting to the right data and modeling it, and you have a data scientist doing like modeling and analytics and also some data modeling, and then you have front-end engineers and designers working on the user interfaces, and then you have more like product people working on testing and getting feedback, then you have a very complicated picture where you need to iterate over a lot of different parts, and doing that quickly and in fast and cheaply is very, very hard. So how many ideas does really get tested, right? And how many ideas can you test in this regime? And how valuable does your idea need to be in order for you to actually set off this framework? How many stakeholders do you need to convince in order to try to put your idea into reality? So how much potential is just gone by this thing? So we started DataButton in order to try to enable this in a different way, basically, that people working in these businesses today could like test their ideas quickly and not having to set up these like huge teams with like long iteration cycles and so on. So DataButton that we built is an all online workspace, all Python, that makes it super easy to go from an idea to an actual data application. So it's a online workspace where you can write Flask apps, but also write the backend and schedule tasks and connect to data in a nice way. And have secrets, and the whole collaboration aspect of it, where you can easily invite collaborators in and you can easily share applications and get feedback on that. So it's kind of taking the Python ecosystem to a level where it's very easy to use and it's easy to distribute, and it's very easy for you to drag in people with domain competence and so on in order to discuss what you're doing. Thank you.